Hello, good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. Today, we are going to study the hydrogen and oxygen reaction which is occurring in atmosphere. From the last 2 days, we are studying atmospheric reactions or dynamics of atmospheric reaction. In that course, we have studied NOx cycle and ClOx cycle. Now, today we are going to study hydrogen and oxygen reaction. Hydrogen and oxygen reaction is an explosive combination process and with which appears to be simple reaction with two reactants, hydrogen and oxygen, but it involved a major species and reaction carriers 16 which is completed in 16 steps. It is for an example of it is an example of chain branching reaction leading to 228.7 kilojoules per mole and is an exothermic reaction. In gaseous state, there is no direct reaction between hydrogen and oxygen. If some free radical is present, or electric discharge is there, or sparking is present, then the reaction takes place rapidly and violently. Two hydrogen react with oxygen to form two water molecules. Here, hydrogen and oxygen are radicals. We have placed star or dot above the hydrogen and oxygen atom, radical, not catalyst but inhibitors of the reaction, and obtained by dissociation of hydrogen and oxygen by the following steps. It means that hydrogen and oxygen reaction, the free radicals which are formed, they does not act as a catalyst, but they act as inhibitors of the reaction, and they are obtained by the dissociation of hydrogen and oxygen by the following steps. In step 1, hydrogen molecule with a rate constant of W0 converted into 2H free radicals. Okay, this is and next step, oxygen with W0 forms two oxygen free radical atoms, and these two steps are initiation steps, and W0 is here rate. Okay, and the reaction of breaking of hydrogen, it involves 5.1 electron volt of energy, and reaction which involves breaking of oxygen radical involves 4.5 electron volt of energy. For dissociation of hydrogen, the enthalpy change is 5.1 electron volt, and for oxygen delta H is 4.5 electron volt. For formation of oxygen and hydrogen bond, now the bond of hydrogen is broken down, oxygen is broken down, and to formation of hydrogen water molecule, bond between hydrogen and oxygen is to be formed. The enthalpy of this bond is equal to 4.4 electron volt. What is the energy? Its energy is 4.4 electron volt. If the value of these these delta H are taken into account, the following steps can also be added for complete dissociation mechanism of hydrogen and oxygen reaction. First है oxygen OH combines with hydrogen so that hydrogen free radical is formed and water molecule is formed. This is K1 rate, occurs with K1 rate constant. Second step, a hydrogen free radical formed reacts with oxygen molecule and forms oxygen free radical and OH. The first reaction is known as chain propagation step. Third reaction and then fourth reaction, the oxygen formed in second reaction takes part in the third reaction, and oxygen free radical here reacts with hydrogen to form OH and H with rate constant 3 K3. The second reaction and third reactions are known as chain branching reactions. In the next step, hydrogen free radical combines with wall. It collides with the wall of the container and is converted into half hydrogen molecule with rate constant of 4,2. It means this is now in molecule form and is not a radical, so it will not react further as a radical, or it will not propagate chain. This is chain termination. in the second step, this is also possible. Oxygen and oxygen or hydrogen, oxygen molecule and hydrogen atom collide with a third entity M present in the system, and with a rate constant of 5, it is converted into water, and M is regenerated. These fourth and fifth steps are known as chain terminating steps. According to the enthalpy changes, the equation is endothermic, that is 5.1 electron volt minus 4.4 electron volt. Such a high energy makes this reaction slow. ठीक है, क्योंकि हाई एनर्जी इन्वॉल्व है इसके अंदर, इसलिए इसकी ये रिएक्शन जो है स्लो स्पीड से होता है. इक्वेशन 3 and equation 1 involve breaking of hydrogen bond. Delta H for reaction is 0.1 electron volt, that is 4.5 electron volt minus 4.4 electron volt. Thus the reaction 3 and 1 are relatively faster. Reaction 1 and 3 are relatively faster because in the first there is propagation step and there is breaking of hydrogen bond, and in the third step there is breaking of again hydrogen bond and formation of oxygen and hydrogen bond. Equation 2 and 3 are chain branching because have reaction of one radical result in production of two radicals. The principal chain carrier is hydrogen atom. The rate of decomposition at these radicals of hydrogen can be given as, now from these equations we will determine the rate of formation of hydrogen, rate of formation of oxygen, rate of formation of OH, and so that we can calculate the rate of this above reaction. So applying steady state concept, d by dt of H free radical, ठीक है, इज इक्वल टू डी बाई डी टी ऑफ एच. इसको हम फ्री रेडिकल ऐसे भी लिख सकते हैं, एक एटॉमिक फॉर्म में भी लिख सकते हैं. ये किसके बराबर है, आप देखिए इसका फॉर्मेशन किस में हो रहा है, फर्स्ट रिएक्शन में हो रहा है, और इसकी रेट कितनी है, W0. तो रेट ऑफ फॉर्मेशन रेट ऑफ उसके डिसअपीरेंस के बराबर होता है स्टेडी स्टेट कंसेप्ट से. तो डी बाई डी टी ऑफ एच फ्री रेडिकल इज इक्वल टू W0 माइनस K2. K2 कहाँ पर है, सेकेंड स्टेप है, K2 इंटू कंसनट्रेशन ऑफ H इंटू कंसनट्रेशन ऑफ O2. रिएक्शन सेकंड को देखिए, K2 इंटू दो H और ऑक्सीजन का पार्टिसिपेट ले रहे हैं तो उनकी कंसनट्रेशन पर रेट डिपेंड करेगी, प्लस K3 इंटू H और H2 इंटू O. जो थर्ड रिएक्शन को देखिए, प्लस K1 इंटू OH इंटू CH2 माइनस K4 इंटू कंसनट्रेशन ऑफ H माइनस K5 इंटू कंसनट्रेशन ऑफ H, कंसनट्रेशन ऑफ O2 एंड कंसनट्रेशन ऑफ N. H ion concentration treated as total free radical density N, meter N. For radicals such as OH ions and O ions, O radicals, the rate is given by d by dt of OH. From these reactions, it is given by K2 into concentration of H and in concentration of O2. You can write this equation by your own because I have explained the steady state concept in detail in all the kinetic lectures before. Plus K3 into H into H2 into O minus K1 into concentration of OH ions into concentration of hydrogen ion, this is equation number 1. Now d by dt of oxygen इज इक्वल टू, दो स्टेप्स के अंदर ऑक्सीजन का काम हो रहा है. एक तो है सेकंड स्टेप जहाँ पर ये कंज्यूम हो रही है, और एक है थर्ड स्टेप जहाँ पर ऑक्सीजन एटम कंज्यूम हो रहा है. इसमें सेकंड में ये बन रहा है और थर्ड में कंज्यूम हो रहा है. तो डी बाई डी टी ऑफ O is equal to K2 into concentration of H into concentration of oxygen minus K3 into concentration of O into concentration of CH2. On applying steady state approximation, d by dt of OH is equal to d by dt of O, and this is equal to 0. From equation 2, we get that K2 into concentration of H into concentration of O2 is equal to K3 into concentration of O into free radical, and it is a concentration of hydrogen. Hence, applying steady state concept on concentration of oxygen atom, we came to a point that K2 into H into concentration of O2 upon K3 into concentration of H2 is equal to concentration of oxygen by applying steady state concept. This is equation number 3. From equation number 1, K1 into concentration of OH into concentration of hydrogen is equal to K2 into concentration of H into concentration of oxygen plus K3 into concentration of O and concentration of H2. This we have already studied, written in above equation. Now we have to determine the concentration of OH in steady state form. Then concentration of OHSS is equal to K2 into H into CO2 concentration plus K3 into O into hydrogen concentration divided by K1 into concentration of hydrogen. This is equation number 4. Substituting the value at oxygen S steady state into equation 4, which is OH concentration steady state, we come to an equation OH at concentration at steady state is equal to K2HO2 concentration plus K3H2 concentration into K2 into H into O2 concentration divided by K3H2 concentration and whole divided by K1CH2. Okay. Now from hydrogen to hydrogen concentration cancels out. Now the oxygen OH concentration at steady state is equal to 2. 1 K2HO2 is before plus sign and 1 K2H2O is second part. So it combines, we add the both, then we get 2 K2HO2 upon K1CH2. Now substituting the value of OH and O in the rate for hydrogen free radical, for the equation for hydrogen free radical. ठीक है, that is oxygen concentration equation 5. Then d by dt of H is equal to W0 minus K2 into H into O2 plus K3 into CH2 into K2HCH2 upon K3CH2 plus K1 in CH2 and this is equal to into 2 K2HCO2 upon K1H2 minus K4 concentration of minus K5 concentration of H, O2 and concentration of M. यहाँ पर क्या क्या कट जाएगा, K1H2 से K1H2 कट गया, K3CH2 से K3CH2, K1CH2 से K3CH2 ये कट गया, तो हमारी W क्वेश्चन बच गई W0 plus K2HCO2 plus 2 K2HCO2 minus K4 concentration of H free radical and K into H into O2 into M. This is we written as W0 plus 2 K2H into oxygen concentration minus K4 into hydrogen ion concentration minus K5 into H ion concentration, oxygen concentration and metal concentration. So d by dt of H is equal to W0 plus in bracket 2 K2 CO2 2 K2 oxygen concentration minus K4 minus K5 oxygen into M concentration in bracket close, H ion concentration is common, H free radical concentration is common. This is equation number 6. Now W0 we can write it as W0 is plus F minus G into N and this is N. आपको अभी बताया था N क्या है इसके अंदर, N है H ion treated as total free radical density is अपने N. So we can write W0 is equal plus ब्रैकेट में F minus G into N. This is equal to W0 plus N W0 plus N divided by F minus G. ठीक है, पूरे इक्वेशन को F minus G से डिवाइड कर देंगे तो F minus G से F minus G क्या हो जाएगा, कैंसिल हो जाएगा, तो ये बच जाएगा. Where F stands for production and G stands for decomposition. Now two limiting conditions are possible. First is F concentration is very very high than G. It means production is very very high than decomposition. In such a case, d by dt of H will be equal to W0 plus Fxn. ठीक है. In second case, F is less than G. Under such condition, dH का हम इंटीग्रेशन करेंगे इज इक्वल टू W0 प्लस Fx इंटू dt, इसका इंटीग्रेशन करेंगे. If F is greater than G, then the value of N can be calculated as N is equal to W0 upon F minus G e raised to power F minus G into T minus 1. If G is greater than F, then N will come out to be W0 into G minus F into 1 minus e raised to power minus G minus F into T. The plot at the function W0 minus Fg or W0 upon G minus F versus time will be obtained. Now, this is the x on y-axis. We have taken W0 upon G minus F or W0 minus F minus G, and then it is taken as time. Now, this type of curve is obtained when F minus G, if this is equal to F minus G, and the upper curve is formed when it is G minus F, then it is G minus F. If the plot made between total rate and the pressure, various situations are indicated. First situation is rate और pressure में ग्राफ खींचेंगे तो first is slow step and the chain reaction explosion होता है, ठीक है. First इसमें second curve is like this U shape. In third and fourth, there are thermal explosions. Apart from these reactions, as given in the mechanism, the other steps are also important, which are as follows. जो हमने इतने स्टेप्स देख लिए उनके अलावा ये स्टेप्स भी हो सकते हैं. 2 water molecules form H2O2 and oxygen. Hydrogen molecule combine with water HO2 to form H2O2 and H. Third step में H combine with HO2 to form 2H and 2H plus O2. H2O2 combines with M to form 2H and M. H plus H2O2 combines to form water and OH ions. OH combines with H2O2 to form H2O plus HO2. H plus OH plus M gives you H2O plus M, and H plus M gives you H2 plus M. This is how the formation of dynamics of hydrogen and oxygen reaction take place in the environment. Now, next lecture we will study about the methane oxidation. Thank you.